All right, here we're looking at section 7.5, and our learning targets are factor x squared plus bx plus c. So whenever we're typing math, it can be really hard to make exponents, so we can use this caret to denote that it's an exponent. And then our second learning target is use factoring to solve real-life problems. So here's our core concept, and I'm going to simplify this a little bit so we can walk through it. So I've got x squared plus bx plus c. I don't care at this point when c is positive or negative. We're going to look at them both together. So the big thing I note is I want to deal with c, and I'm going to be dealing with b. So this trinomial is going to factor into two binomials with what we're going to call p and q. And I know that these are just going to be different numbers. And the way I can find those numbers is when I add them together, they're going to equal b, and when I multiply them, they're going to equal c. Okay, so just ignore this part. We're going to get there in just a minute, but we're going to make it a little bit easier. So let's look through an example, because sometimes that can help a lot. So I'm supposed to factor x squared plus 10x plus 16. So the first thing I want to do is find what p times q would be. So I want to find all of my factor pairs of a positive 16. Well, I know that if I multiply 1 times 16, it gives me 16. 2 times 8. 3 doesn't work, but I know that 4 also works. And I know I don't have to continue. So first I find all the factor pairs of my constant term, the term that's all by itself. So now I have to figure out what they all add to. So let's go ahead and do that. So I know that 1 plus 16 is 17, 2 plus 8 is 10, and 4 plus 4 is 8. Now I'm looking for this middle term, the b, and I see that it is right here, that this middle pair adds to 10. So this is my p plus q. So now I can go ahead and rewrite this factored out. So I'm going to always write my set of two binomials. My first term in both of those will be x. Then I can go ahead and fill these in. So my 2 is going to go here. So I now have x plus 2. And my 8 can come over here. So I have x plus 8. So I want to just double check this one. We don't have to double check every single time, but I want to show you how that it does really work. So I'm going to go ahead and multiply these two together. So I've got x times x plus 8 plus 2 times x plus 8, right? I'm just multiplying, and I generally multiply horizontally. Either way you do it, you'll come up with the same thing. So x times x is x squared, x times 8 is 8x, 2 times x is 2x, 2 times 8 is 16. So now I see I have my two middle terms that I can combine. So I have x squared plus 10x plus 16. So I see here that I ended up with the same thing that I started with. So I know that these factors are correct, right? And all I did was I figure out the factor pairs of my constant term, and then I add them together and see which set adds to the middle term. That's really all we're going to be doing here. It doesn't matter positives, negatives, any of that. It'll work the same. So let's look at a different example. So here I see I have a negative sign. We're going to do the same thing. So I want to find p times q. Okay, so again, I find all of my factor pairs of 12. Well, I know that 1 times 12. I also know that a negative 1 times a negative 12 will still give me a positive 12, right? Because a negative times a negative is a positive. So I know I can have 2 times 6, but I can also have a negative 2 times a negative 6. Then I can have a 3 times 4, or I can have negative 3 times a negative 4. Any of these, when I multiply them together, will get me this 12. So now I want to add them together. Well, p plus q. So 1 plus 12 is 13. A negative 1 plus a negative 12 is a negative 13. 2 plus 6 is 8. Negative 2 plus negative 6 is negative 8. 3 plus 4 is 7. And negative 3 plus negative 4 is a negative 7. So now that I've added them all together, I want to see what will add to this middle term, which is a negative 8. And I see that right here. So I know I'm going to be using these two factor pairs. So again, I write out my product of binomials. So I have x as the first term in both of them. Then I'm going to have a negative 2 here and a negative 6 here, because of the signs of the factor pair that I multiplied together to get this middle term. So you'll see my negative 2 just goes in here, and then my negative 6 goes in here. I could also write this as plus a negative 2 and plus a negative 6. It's the same thing. So as long as we make sure that we have that negative sign in there somewhere, we're good to go. Okay, so this will work. This strategy that we're using will work for any trinomial that we're trying to factor. And I'm not going to right now, but I could go back and multiply this out and just double check that we get where we started, just in case I want to try it. Okay, so I'm going to skip this core concept because it works the same way no matter what. So let's find all of my factors, my p times q, of a negative 21. So I know I could have 1 times a negative 21, wrong button, times a negative 21. I could have a negative 1 times a positive 21. I could have a 3 times a negative 7, or I could have a negative 3 times a positive 7. These are all of my factor pairs of a negative 21. So now let's go ahead and add them together. 1 plus a negative 21 is a negative 20. Negative 1 plus a positive 21 is a positive 20. 3 plus a negative 7 is negative 4. Negative 3 plus a positive 7 is a positive 4. So now that I've added them all together, I look and see what my b term is in my polynomial, and I see that it's 4, a positive 4, so that tells me I'm going to use this bottom set of factors. So again, I can write out my polynomial, my binomials, with x being the first value. This first one's going to be a negative 3, the second one's going to be a plus 7. And here's where I get those from. It doesn't matter which order. At this point I put the 3 or 7 in. I could have x plus 7 times x minus 3, right? So I'll say or x plus 7 times x minus 3. The biggest thing to keep in mind is this negative sign has to go with my 3, but that's what I was shown here. So it doesn't matter where the positives or negatives are. Up here is when it's where we follow, making sure the negative sign follows that letter, that number that it's with. Okay, so here are some practice ones. Try them, and try several of these because we've got some with a negative early on, and I've got some with a negative later on, and I've got one with a negative in both places. Why don't you try these 3 for me and see how you do, just using the same strategy that we've done. So now here's our real life example. Okay, so a farmer plants a rectangular pumpkin patch in the northeast corner of a square plot of land. The area of the pumpkin patch is 600 square meters. What is the area of the square plot of land? So the first thing I always do is I draw a picture and I label what I know. Well, so I know that this is 600 square meters. So I'm trying to figure out the rest of the plot of land. So I want to deal with the side lengths of the square. And I know it's a square because I'm told that above. Well, so I know that this length, let me get a different color, this length right here is going to be s minus 30. And I know that because I can see that this side length is s, but I already have 30 here, so I know that this is going to be the rest of it. And same thing with the top. This is going to be an s minus 40. Okay, so I see that this is going to be here. Well, and so now I was told what this area was, and I know to find the area of a rectangle, I multiply the 2 sides together, and it equals whatever I was told. And here I was told it's 600 square meters. So let's go ahead and multiply this out. So I've got s times s minus 40 minus 30 times s minus 40 equals 600. Now I have to do this because I don't have a 0 on this side, right? If I had a 0 over here, I could use my 0 product property to solve, but I don't yet, so I have to do this step first. So let's multiply it out. So I've got s squared minus 40s minus 30s plus 1200 equals 600. So I see I have some terms that I can combine. So I end up with s squared minus 70s plus 1200 equals 600. So now I want to get everything to one side. So I'm going to subtract that 600. So I end up with s squared minus 70s plus 600 equals 0. Now that I have a 0 on this other side, I can go ahead and I can factor this trinomial. So I want to come up with my factor pairs of 600. Well, I know that that's going to take me quite a while because there's a lot of them. So one thing I notice before I do that is that I have zeros at the end of both of these, right? And so I can think about I'm probably going to be dealing with tens of things. Let's just try it and see if it works. So I know to get a positive 600 by using tens, right? I could have 10 times 60, or I could have a negative 10 times a negative 60. So when I add them together, I end up with 70 or a negative 70. And it did end up working because this is what I'm looking for right here in the middle term. So now I can write my binomial, my product of my binomials, equals 0. So now that I have this multiplying together equals 0, I use my zero product property. So s minus 10 equals 0 and s minus 60 equals 0. Then I solve. So s can equal 10 and s can equal 60. So here I'm given two answers, but I know that only one of them can work. So I look back at my picture and to see which one I think is going to work the best. I notice that this side length, right, and we're dealing with side lengths because s, so this side length can either be 10 or it can be 60. Well, if it's 10, it doesn't make any sense because over here I'm already told that pieces of it, a part of it is 30. So how can I have a part of it be 30 and the whole thing be 10? It just doesn't quite make sense if I measure it out. So I know that my s is going to be 60. So I'm not quite done yet because the question I'm really asked is what is the area of the square plot of land? Well, I've found the side length, so I know that to find the area, I multiply my two side lengths together, which is 60 times 60. 6 times 6 is 36, and there are two zeros. So this right here is going to be my answer. The square plot of land is 3,600 square meters. So I had to go through the multiplication and then factoring to find my side length. And I found that this value didn't really work mathematically, and it didn't make sense using my picture and my real life drawings. Okay, so here's another problem to solve. So this is going back to that same picture. It's just changing things a little bit. So see if you can start from scratch here and end up with a solution. So now let's look back at our learning targets. Okay, factoring x squared plus bx plus c. And remember, it doesn't matter if these are negatives. We follow the same steps and same strategies. And then our second learning target was use factoring to solve real life problems. And we did that with our pumpkin patch. So first we have to draw our picture and then figure out what we know and what we're looking to find. Then we can factor and solve. So now it is time for you to go ahead and work on that homework for 7.5.